So let's discuss a problem from electromagnetism. So this is related to the topic electric field due to circular ring of uniform line charge density. So you would be given a circular ring consisting of uniform line charge density. So we need to find electric field because of that. So here is the question, not only electric field, some other points also. So here a circular ring of radius A carries a uniform charge rho L coulomb per meter. So here we need to consider a circular ring. So it is a ring and it is of radius A. So its radius is A of uniform charge, that is the entire ring is having charge density uh, of uniform charge rho L coulomb per meter. That means charge for unit length. So that is nothing but rho L and is placed on the xy plane with the axis same as the z axis. So this ring is placed in xy plane with axis as the z axis. So best diagram is this. So here you can see this is x axis, this is y axis. So the ring is lying in this plane. So it is lying in this xy plane and this is z axis perpendicular to this. So its axis is in the direction of z. So this so it is lying in this xy plane perpendicular to this. So this is the arrangement, actual arrangement. So we need to show that E of 0 comma 0 comma h is this. So this one we need to show electric field at certain height. And next point B is values of h given the maximum value of E. So for what value of h gives the maximum value of E. So that one we need to see. Total charge on the ring is Q, find E. So if the total charge on that ring is Q, we need to find E. As A tends to 0, we need to find E. So this is the question. So for this we need to use this formula here. So this rho L is nothing but charge per unit length, that is charge per unit length, that is nothing but lambda. Actually we used to indicate it with lambda, but here it is given as rho L. So integration of actually we know that electric field is nothing but 1 by 4 pi epsilon naught into q by r square. So it is into q by r square. So this is the formula for electric field. So here 1 by 4 pi epsilon naught r square, everything as usual. Q is nothing but dou L into dl, rho L into dl. So in the place of, instead of indicating with lambda, here it is given as rho L. That means length charge density, that is, and surface charge density is actually sigma, but it is given as rho S. That is nothing but charge per unit area. So this is for surface charge and this is for the volume charge. So here it is indicated as rho V instead of rho. So that's so here instead of lambda, rho L is nothing but equal to lambda. So notations have been different here. So we need to use this formula. So that is, in the place of Q we are having this entire thing. So lambda into L is nothing but Q, rho L into dl, charge for a certain length of the ring, small unit length of the ring. So if we do integration for the entire length, we would get the electric field. So Q by 4 pi epsilon naught r square, and this is unit vector. So it is just a cap, just like r by magnitude of r, that is nothing but a cap. So this is just unit vector used to indicate direction, because electric field is a direct vector quantity. So in order to show the direction, it is there here. So we need to use this formula for this. So first of all, this is the arrangement. So here this is the ring, and here we are considering a particular element of the ring, dl element of the ring, not the entire ring. So we just consider a particular dl element and just we integrate, because here dl is there. So we just integrate over the entire ring later on. So we need to find it on the z axis. So this is the z axis. So from here to certain point on z axis we have drawn a line. So that is this is that line. So this is the line and it is of length r. So r with some vector so it is of direction r. So that means its length and direction is r, capital R. So from here to here the length and direction is r. So magnitude is magnitude of r, and here from here to here electric field is acting in this direction. This is the direction of electric field. So if we consider a positive charge like that, so for positive charge electric lines of force will be acting in outward direction. So from here, because of this effect, so here it is pointing out in this direction, and the angle between this vector and z axis is alpha. So here also the same, the angle between DE and z axis would be alpha. So if we divide that one into two components, so this is DEZ and this is DER. So this is DEZ, so this is DEZ and this is DER. So DEZ, DER. So here DER. So this is along z axis, electric field component along z axis. This is in along xy plane. So along xy plane we are having x coordinate and y coordinate. So both of them put together, here it is written as dou e rho, like that. So just like r. So we know that the square root of x square plus y square is nothing but r, like that. Y square is equals to r. So like that, square root of x square plus y square is equals to r. So dou e r, so that is along the xy plane. So this is, so here we should not get confused. So this is along xy plane and this is along z axis. So xy plane is always perpendicular to z axis, that is z axis is perpendicular to xy plane. So like that. So this component is and this is z component, like that. So that is a division of component, and here to here, this from this point the height is h, and here radius of the ring is a has given. So now consider the system as shown in figure. So first of all we need to write what is dl. So dl is nothing but, so this is some arc of length dl. So if we define, it is making an angle d phi. So here, so if this is a circle, if it is an arc of length, it would be making some certain angle. Theta is, so this is radius of the circle. So theta is nothing but L by R. So here in this case we are having d phi. So here it would be making an angle d phi is equals to dl by A. So radius of the ring is A, as the radius of the ring is A. So that's why. So dl is nothing but A d phi. So dl is nothing but A d phi. So this is the thing we are having. And next is, so this very important thing is this one we need to keep an eye on. So this R is divided into two components. So one in this direction, that is perpendicular to xy plane. So that is HAZ. So this point is at a distance h from the xy plane. So that's why HAZ. AZ is nothing but k cap. Instead of k cap, here it is used as AZ, and it is moving in this direction from this point to in negative direction, like that. So just like origin, this is positive, this is negative, like that we used to take. So here it is not coming outwards but is going inwards, like that. So here at this point, so that is nothing but minus k in radial direction. So minus a rho. Rho is nothing but radial direction. Radial direction, that means nothing but xy plane. here. So here only z coordinate would be coming. So for this component only z component, for this height only z component would be coming, but for this radial direction both x and y coordinates put together would be coming. So that is nothing but overall it is given as x plus x square plus y square is nothing but r square. So that is nothing but radial direction. So hence it is indicated as minus a rho. A rho is nothing but radial direction. So these are that is about the components. So this one we need to understand first of all these two. So that is how we have got. And next, magnitude of r is nothing but square root of a square plus h square. So here this is r. So its magnitude, finding its magnitude is nothing but this is this component plus this component whole square. So here you can see right angle triangle also. So easily here you can see right angle triangle. So this is r, so this is h, and this is a. So it is like this h a r. So r is nothing but square magnitude of r, that is magnitude of r square root of a square plus h square. So square root of a square plus h square. So we know that ar is also r vector by magnitude of r. So in order to get unit vector direction, so next is we need to divide ar by r square. We are dividing because in the formula we are having ar by r square. Here in the formula ar by, that is unit vector in r direction, radial direction, that is in the direction of r by r square. Hence ar by r square, that means ar is this vector r by r divided by r square, that is nothing but vector r by r cube. So position vector divided by vector r by so this entire thing divided by r square, that is r square. So that is nothing but vector r by r cube. So hence we are having r cube like that. So r is nothing but this minus a rho plus h a z. So that one here we are having, and this whole cube a square plus h square. So r is nothing but a square plus h square root whole cube is nothing but a square plus h square whole to the power of 3 by 2. So that one we are having. So this is the thing. So ar by r square r cube, which we have derived now only. So in the place of capital R we have placed this and r cube this. So next is we just need to place this in the formula. So formula, that is in the page. So here rho l by 4 pi epsilon naught would be taken out. So rho l by epsilon naught. So rho l by 4 pi epsilon naught has been taken out, and next thing is dl has been replaced with this. So dl is nothing but a d phi. So it is replaced with a d phi. So a d phi, and ar by r square is replaced with this. So that is the thing which was remaining. It is, so here is ar by r square. Remaining thing is this only in the formula. So ar by r square. So where is it? So here ar by r square is nothing but r cube by r. So in on multiplying with r and the numerator and denominator we will get r, magnitude of r into r is nothing but r. So this is the thing we are getting. So this is the replacement, and we need to integrate from 0 to pi because we are here d phi is there. So 0 to 2 phi. So for the complete circle 0 to 2 phi is the angle. So now another thing is, by symmetry the contributions along a row add up to 0. This is evident from the fact for every element there is corresponding element diametrically opposite gives an equal but opposite to E. So the two contributions cancel each other. We are left with z components. So if we consider the if we consider this ring, So for this element, for this every element, there would be another exactly opposite element, exactly opposite to this. So it would be offering electric field magnitude in this direction. So here it would be in this direction e rho, but z component would be in this direction. So if you see uh, this z component, that is this z component and this z component, both are in upward direction, but this ar component and this ar component would be in exactly opposite direction and of equal magnitude because of the symmetry in distance, symmetric circle. So they both would get cancelled, only z components would be remaining. So it is just like for this element, ez is in this direction, ez's, and e rho is in this direction. And for this component, e rho is in this direction and ez is in upward direction only. So these both directions, that is these both directions would get cancelled up, only these directions would be remaining, so they both would add up. So we can neglect radial components in the formula. So that means we can neglect this component a rho, a minus a rho. So only what would remain is haz and this entire thing. So hence here haz and this entire thing, h square plus a square whole to the power of 3 by 2, only that one is remaining, and 0 to 25 d phi. So 0 to 25 d phi, and here a has been taken out. So a has been taken out, haz. So this is the thing we are having. So this would be remaining, and we need to integrate it from 0 to 2 pi. So integration of d phi is nothing but phi, the phi 0 to 2 pi, so 2 pi minus 0. So getting 2 pi and pi would get cancelled, 2 ones are 2 twos are, so 2 epsilon naught. So rho l ah az cap and h square plus a square whole to the power of 3 by 2. So this is the remnant. So this is the things which was asked. So finally we have found electric field because of the circular ring whole to the power of 3 by 2. This was the thing was asked. So it is same as this which we have proved now. So next thing is they have asked us at what value of z e would be maximum, which value of z e would be maximum. So z is nothing but h, with height, how the electric field is varying. So if dou e by dou z, so if we draw a graph between e and h, so e and h, so suppose it would be like this. So at some particular point electric field is magnitude. If we draw a tangent, so here tangent is nothing but dy by dx, so de by dh. So that must be parallel to this h axis, that is nothing but tangent, slope is nothing but tan theta, tan 0 is 0, so parallel to this axis, h axis. So hence de by dh must be equal to 0. So de by dh must be equal to 0. So hence we are differentiating this with respect to h. So on differentiating, so here in the numerator also we are having h, in the numerator 1h we are having, and here also h function is there. So it is just like u by v. So we need to use the formula v du minus u dv by v square on differentiating this term. So here rho l by 2 epsilon naught, rho l a by 2 epsilon naught is there, so rho l a by 2 epsilon naught, like that. So v h square plus a square whole power of du, so dh by dh 1 minus u dv minus this u dv. U is nothing but here h. So in the place of u we are having h here, in the place of v h square plus a square whole to the power of 3 by 2, that is this entire thing, h square plus a square whole to the power of 3 by 2 is there in the place of this. So v du minus u dv, u is nothing but h, and differentiating v, we will get n into x power n minus 1. So 3 by 2 into h square plus a square whole to the power of 3 by 2 minus 1. So that is nothing but half, square root of half. And again we need to differentiate this term, this function. So on again differentiating 2h, so we are getting into 2h. So that is the thing. So if we differentiate this v value, we would get this entire thing except h. So this is based on the integration. And next thing is, so it is based on the integration h square plus a square whole to the power of 3 by 2. So on, sorry, it is based on differentiation. So on doing differentiation we will get, and finally by v square. So v square is nothing but this whole square, that means 3 by 2 whole square, 2 would get cancelled, whole cube. So h square plus a square whole to the power of 3. So for e to be maximum, d by dh must be equal to 0. So this entire thing must be equal to 0. So this thing must be equal to 0. So this everything would get, go to that side, and what would remain is only this thing, the numerator value. The value of the numerator would be remaining. So here we need to just take square root of h square plus a square out. So from here what would remain is 2 would get cancelled, minus 3h square. So minus 3h square, and square root of h square plus a square here also. H square plus a square would be remaining here. Square root of a square, h square plus a square, if we take common, h square plus a square would be remaining. So that h square plus a square, and this we just need to equate it here to 0. So here if we do equate this, so here if we see a square minus plus h square minus 3h square, that is minus 2h square. So a square minus 2h square equal to 0. So sending that 2h square to that side, so 2h square, so a square is goes to 2h square, and taking, on taking square root, so sending this 2 to that side, a square by 2, that is a by root 2, plus or minus a by root 2. So that is the thing we are getting. If we equate it to 0, we would get in negative terms, minus I like that, because h square is goes to minus a square like that. So minus I like that we will get. So we don't want complex numbers, so h is nothing but plus or minus a by root 2. So at this height, a by root 2 height, electric field would be maximum based on this. And next what they have asked us is in the question. So next what we need to prove is, if the total charge on the ring is q, find E as a tends to 0. So the total charge on the ring is q as a tends to 0. That means if the radius of the ring tends to 0, that means if this ring goes on shrinking, and finally if its radius becomes 0, the ring is going on shrinking, and it is getting concentrated to a certain point. So the entire ring is having charge capital Q. If it shrinks, finally it becomes a point charge Q. So at that time what is the electric field? That one they are asking. So for that, so we know that charge per unit length is nothing but Q. The entire ring is having charge Q, and its length is 2 pi r, because it is a ring, circular one. So length of the ring is nothing but circumference of the ring. So 2 pi r, 2 pi a is the radius. So Q by 2 pi a. So we just need to substitute this in electric field formula. So here this is the electric field formula. So in the place of rho L, Q by 2 pi A. So Q by 2 pi A. So A would get cancelled. So here already 1 A is there. So in the denominator 1 A, 2 pi 2 into 2, 4 pi epsilon naught would become. So from there we have got. So 4 pi epsilon naught, and H and this entire thing would remain as usual. A would have get cancelled. So finally you would have this az, and here as a is tending to 0, so a tends to 0 they have given, so in the place of a we need to keep 0. H square whole over 3 by 2, so square square would get cancelled, and h cube that is number h cube we are having, h and 3 would get cancelled, h square q by h square, q by 4 pi epsilon naught h square az. So in general, in the place of h we could replace it with r square, so q by 4 pi epsilon naught r square ar. So this is same as that of the point charge as one would accept. So for the point charge, 1 by 4 pi epsilon naught q by r square, that is the 1 by 4 pi epsilon naught q by r square, that is the value of electric field. So the same value we have got. So after simplification, here a square has been eradicated, so a is nothing but 0, so it has been eradicated, 2 would get cancelled, and h cube would get cancelled, so q by h square, so q by 4 pi epsilon naught r square ar. So same as for the point charge we would get, so same thing we have got from this derivation. So finally it is correct. So this is the solution, these are the problems, side by side problems in this question. So this is the derivation, these are the notations are different. So this is the problem, so this is the solution. So thank you.